I believe in 50 to 100 years, we will in fact have rockets that will take us near the speed of light, ion engines, photon engines. They'll take us to the speed of light where time itself begins to slow down.
Professor Mikio Kaku at the City College of the University of New York, physicist, writer, and broadcaster.
One of the most preposterous predictions of Einstein's theory is that the faster a rocket moves, the slower time beats within that rocket ship. Imagine somebody taking off near the speed of light, and you're sitting on the Earth with a telescope. As you look in your telescope, looking at the rocket ship, you see that everyone inside is frozen in time because the rate at which time beats has actually slowed down. Now, we've actually measured this in the laboratory with atomic rockets, with satellites. We can actually measure the fact that time slows down the faster you move.
In 1975, Professor Carol Alley of the University of Maryland set out to test Einstein's theory with two synchronized atomic clocks. One was flown on board a military plane, while the other stayed behind on the ground. After the flight, the clocks were found to be ever so slightly different in the time they told. Time dilation is even more pronounced for the crews on long missions aboard the space station Mir. But what might have remained an obscure footnote in quantum physics could become the most fantastic element of our future in space. And once again, science fiction was the inspiration.
Carl Sagan, the noted astronomer, was writing a science fiction script called Contact, meeting extraterrestrial life forms. But he had a problem. The distance between stars is so great that it would take centuries to visit other planetary systems. And because of the time dilation problem, he decided to ask a physicist, is it possible to go these enormous distances in a twinkling of an eye?
Sagan called Professor Kip Thorne, a noted expert on Einstein's theory. Thorne struggled with the problem for some time. Then, in the back of a Ford Bronco, as he was driven along Interstate 5, he made one of the most inspiring connections of modern physics by linking Carl Sagan's cosmic conundrum with the exciting new concept of wormholes.
A wormhole is a hole in space that may give us a shortcut between 2 points. For example, if I had a super microscope and I could peer right into the fabric of space and time, I would find that it's not smooth at all. It's foamy, it's frothing with tiny little holes and bubbles. If science can somehow tease apart one of these holes in space, we could actually connect two distant regions of space and time. Now, where have you seen that before? In Alice in Wonderland's Through the Looking Glass. The wormhole was Alice's looking glass that connected the countryside of Oxford with Wonderland, such that when Alice stuck her hand through the looking glass, her hand went through the wormhole and came out on the other side of forever.
Thorne was triumphant. Wormholes were an exhilarating means of connecting 2 points in space. It was only later that the full implications hit him. If wormholes could cheat space, they could also cheat time.
It was disconcerting to see the sun arc in less than a minute. To see a snail race by, my flowers flinging wide their petals to embrace the new day, and the hours speeding across the face of my sundial, and the flowers closing their eyes for the night. It was wonderful.
After years of fantasy, this incredible development allows us to imagine the impossible, something that mainstream science had refused to consider. For the first time, we can dare to speculate on the workings of a practical, functioning time machine.
Now, this is not going to be like H.G. Wells' famous novel, The Time Machine, where you sit in a chair, have a bunch of blinking lights and dials, and literally rocket hundreds of thousands of years into the future. That's not what it's going to look like. Let's go through the steps by which we physicists think you can actually build a time machine. First, on the planet Earth, build two gigantic metal plates and charge them up with fantastic amounts of energy. Step number 2, right next to it, build a carbon copy, two parallel plates, and charge them up. And the Casimir effect will take place. A small wormhole will begin to open up between these two parallel plates. Now remember, the Casimir effect is not science fiction. We've actually observed the beginnings of the Casimir effect in the laboratory. Step number 3, get a rocket ship. Put the carbon copy into the rocket ship and send that into outer space, leaving the first set of parallel plates on the Earth. A wormhole, an umbilical cord, will connect the parallel plates on the Earth with the parallel plates in the rocket ship. Step number 4, as you approach the speed of light, time dilation occurs, time slows down, and these two parallel plates are no longer in synchronization with respect to space or time. And the last step, jump into the set of parallel plates on the Earth. You will immediately be sucked right through this umbilical cord to the other set of parallel plates existing in a different point in space and a different point in time.